Hello, beautiful people, and welcome to Chapter 8. Yes, we skipped Chapter 7. We'll come back to it. We're starting with some ratios and proportions. So there is a Desmos on there. That's a pretty good exploration of ratios and proportions. It's the same stuff you learned in 7th grade, hopefully. Basically, a ratio is a comparison of two quantities. It's usually a fraction in simplest form. There's a couple ways to write ratios. So let's say there are 14 boys and 10 girls in Miss Burris's third period. What's the ratio of boys to girls? So it needs to be boys to girls or boys to girls, okay? So that is how you say those. Or, if you make it a number, 14 to 10, I'm going to make it a fraction, 14 over 10, which in simplest form is 7 over 5. So that would be a ratio of 7 to 5. A ratio of 7 to 5. That is the ratio of boys to girls in Miss Burris's class. If you don't know how to simplify fractions in your calculator, there's an ABC button. Let's see if I can pull this up while I'm on screen. Where's my camera? So I can click on this one. I can say 14 fraction, what was it? I don't remember now. It was 14 over 10. And it does 1 1/3, but then I want it to make it a mixed number, so I'm going to go second fraction button, 7 over 5. It's a little easier on the other calculators. The ABC button's simpler. All right, Miss Burris is 5 feet 1 inch tall, and the flagpole is 25. Write a ratio comparing the height of Burris to the height of flagpole. So we need to go Burris over flagpole, okay? So if I do that, 5 feet 1 inch, well, it's really hard to write a ratio in two different units. We want it all to be the same unit, at least on the top and the bottom. So 5 feet 1 inch is going to be 5 times 12, because there's 12 inches in a foot, 60 inches plus 1 more inch. She's 61 inches tall over 25 feet tall. Now, this is an acceptable ratio. It could be better. We could change that 25 feet to inches as well. 61 inches over 25 times 12 over 300. So 61 over 300 is your best answer here. Let's make sure that that cannot be simplified. I'm pretty sure it cannot be. 61 over 100. Yeah, nope, that is simplest form. All right, the measures of two supplementary angles are in the ratio of 1 to 4. What is the measure of the smaller angle? Okay, so this is using ratios and proportions. So we know if you have supplementary angles that add to 180. So we know that these two angles, so we're going to call it, one of it's 4, so that would be the bigger one, right? And one of it is 1, so it's 1 to 4. So we know that these two have to add up to get me 180. Now to do that, I have to multiply them by some number, because they're in a ratio of 1 to 4. That has already been simplified. So it's like my ratio is 1 to 4. I need to know what the totals are. And those two totals need to add up to 180. So what I mean by that, the easiest thing to do is say, okay, this is going to be times some number times some number. So 1x plus 4x equals 180. 5x equals 180. So 180 divided by 5 is 36. So I'm going to say both of these times 36. X equals 36. So that means the smaller angle is 36 degrees. And then 4 times 36 is 144. 144 is the bigger angle. So that is it asked for the smaller angle, might be. The measure of the smaller angle is 36. 36 plus 144 is 120. We're good. So this is how we can use ratios. It gave us the ratio. We have to go backwards into the original number. All right, so that is also an extended ratio. There was an example of an extended ratio in the Desmos. A triangle has these side lengths. Write an extended ratio. So you can't write a triple fraction, so we're just going to go 14 over 24 to 30. Now, you have to be able to divide by every single number in here. It cannot be, oh, this one can be divided by 7, but that one can't be. No, you have to divide them all by the same number. So let's see, it looks like these are all divisible by 2. So I can say 7 to 12 to 15. 7's a prime number. I can't keep dividing. Yes, but Ms. Mayhew, both of these are divisible by 3. Yes, they are, but that one is not, so you cannot keep going. My most simplified ratio are these. All right, salsa recipe. What is the extended ratio of these ingredients? So I have 11 to 33 onion to 77. Those all look like they're divisible by 11 here. You need to know your multiplication facts, team. So it's 1 to 3 to 7 is my extended ratio of these ingredients. So we got to use these extended ratios. Here, they've given me the ratio, and I have to go backwards. The measure of angles in ABC have an extended ratio of 1 to 2 to 3. Well, we know the measures of a triangle have to add up to 180. So we're going to have 1x plus 2x plus 3x is going to equal 180 degrees. 6x equals 180. X equals 30. So let's see, find the measure of the largest angle. So now I can plug that 30 back in to actually get my angle measures. So this was the extended ratio. We're getting the big one. We're getting the OG. So it would be 30 to 60 to 90. So the largest angle is 90 degrees. Same idea. What are the lengths of the sides of the triangle are an extended ratio of the perimeter. So again, we're adding these up. That is the original number. So before, to go from the original to the ratio, we divided. To go from the ratio to the big one, we got to multiply. So 4x plus 7x plus 9x equals a perimeter of 60, because perimeters add up all the sides. So that's 1620x equals 60. X equals 3. So we're going to multiply each one of those by 3 to come up with the length of my sides. So 4 times 3 is 12, 7 times 3 is 21, and 9 times 3 is 27. Those are the lengths of my sides, and they're all going to be centimeters because the perimeter was in centimeters. All right, so those are ratios. Ratios are types of proportions. Basically, if you have multiple ratios, you put them together, they are proportions. So you set 2 ratios equal to each other. So I like colors for these. I suggest you do the same. A and B have a relationship. C and D have a relationship. Also, AC have a relationship and BD have a relationship. So you need to make sure your numbers stay together in some capacity. All right, so I'm going to do this again. So like the A has to always be with the B and the C. The C, let me say that again. The A has to always be with the B and the C. The D has to always be with the B and the C. The A and the D are not together. They are across from each other. And we're going to end up cross multiplying here in a minute, but not yet. All right, so I'm going to draw my A and 7 go together. 13 and B go together. A and 13 go together. 7 and B go together. So if you look, I've already got A and 7 together. So the other one that A needs to go with is that 13. And then 7, the other one that 7 needs to go with is the B. Because 7 and B went together. And now the 13 and the B are together. Good. So it's the same color coordination. I've just kind of spun it. You just need to make sure. So, 7 was orange and pink. 7's still orange and pink. B was green and pink. B is still green and pink. All right. So again, the 7 and the A are together. They just got flopped on top of each other, which means all I'm going to do is flop this other one. So it's going to be the A goes with the 13 as well. The 7 goes with the B as well. Just to show my colors again. 7 and B go together. 13 and A go together. B and 13 go together. All right, so make sure all your colors overlap the same. Now, we can also solve for A. We could solve for B. There are 2 ways to do. So you could set up an algebra problem with cross multiplication. A lot of people like that. There's also going to be a shortcut that's going to be beneficial for us down the road, where you multiply by the 2 numbers that are across from each other and divide by the one that's left out. I'm going to show you both. So here, if I were to set up a cross multiplication problem, what this ends up being is 6 times 4. 6 times 4 is equal to 5 times x. Okay? Doesn't matter what order you write it in, it's all going to be the same. So 24 equals 5x. So x is going to be equal to 20, it's a decimal. 24 divided by 5 is 4.8. The other way to do this, the shortcut, okay? I call it a shortcut. 6 over x equals 5 over 4. Multiply by the two numbers and divide by the leftover. So 6 times 4 divided by 5. And if you put that in your calculator straight up, 6 times 4 divided by 5, it is going to get you 4.8. All right, so there are two ways to do this. I want you to try it, see what you get. First way, 14 times 9 equals 2 times a. Or 14 times 9 divided by the leftover one. So 14 times 9 divided by 2 is 63. A equals 63. It's going to work either way. All right, now, when we get into these, it's a little harder, right? Because there isn't one that's like the numbers one, obviously. So we need to go ahead and set up our algebra problem, okay? So let's see. Y plus 4 times 3. We have to do that whole thing times 3. Not just the y, not just the 4, the whole thing. And then 9 times y is 9y. So 3y plus 12 equals 9y minus 3y on both sides. 12 equals 6y, y equals 2. Boop, boop. And you can always check your work, y'all. So if I come back in here to check my work, I know that y equals 2, so that's going to be 6 over 9. Is that equal to 2 over 3? Plug it in your calculator. They're the same. Same idea here. I have two variables, so it's too hard to do the shortcut. I'm going to cross multiply. 15 times m. Plus, nope, not plus, make you, equals 3m plus 3. I had to multiply that 3 times the m and multiply that 3 times the 1. Minus 3m, minus 3m. 12m equals 3. M equals 3 divided by 12. Which is 0.25, which is 1/4. Any of those answers are acceptable. All right, that is your homework, my dears. Write the ratio of the first measurement to the second measurement. If you need to change some feet and inches, do so. Solve for the indicated variables using extended ratios, and then solve the proportions and set up the proportions. Good luck.